Hello, this is Matthew Harms, and in this video I'd like to show you the capabilities in Capture to develop constraints, edit topologies, and view topologies in Signal Explorer. So I'm going to start with this design that I have here. I have some sources, I have a single net, and I have a resistor in between there going to ground. What I want to do first in this schematic environment in Capture here is I would like to define the models that I want to use for the net that I want to analyze. To do that, what I need to do is go through to the SI analysis mode, and in here you can quickly auto-assign discrete SI models to devices like resistors, capacitors, inductors just by hitting this button. That's going to make for you automatically models for your resistors. So that component's finished. For my other pins here, I can just select the pin and hit assign SI model right here and pick the pin that I want to use and assign it to some models. So I want to use 3.3 volt logic, so I'm going to assign it that model, and I'm going to repeat that step for the receive signal right here, and I'm going to assign it to 3.3 volt logic as well. Once that's done, I've assigned my input-output pins, I've assigned my resistor model. I just need to assign my ground net. To do that, I can just verify that it's correct by going to SI analysis, identify DC nets right here, and verify that my zero net name is attached to the zero voltage value as well. Once that's done, I'm completely done in Capture. All I need to do now is export this. So to do that, I can just grab the net, right mouse button, Signal Integrity, Explore Signal. That's going to take me to Sig Explorer. I'm going to use the OrCAD level of the license for that. And here in Sig Explorer I get to see my topology. So I get to see my nets, my CDS default IO 3.3, 3.3 here, and some default line lengths in between, as well as my resistor and zero ground out there. I can run some analysis, develop some constraints, and then come here and set those constraints right here in Sig Explorer. So I might want to come up with one that that says my total etch length is somewhere between 500 and 1500 mils. So let's set that constraint. That's one that can be easily read in the OrCAD PCB Pro tool. So I'm going to set that. I'm going to save this and overwrite the existing one, and I'm going to update this to Capture, which tells Capture that it's using a constraint set and the name of it is going to be called mynet.top. So we can close out of here at that point, and now we've done some analysis, we've developed constraints, put them here in Capture. I want to now bring those constraints over to the board and verify that they work. So let's go here to Tools, Create Netlist, and I'm going to go off to the board. I just have a start board with some colors and stuff set. I'm going to call this board IBIS. I'm going to open it up in OrCAD PCB Editor, and I'll hit OK to generate that. It's going to save it for me, and it's netlisting the design now for me. It's going to open up the OrCAD PCB SI tool, and here in the tool I can place my components here if I want to. So I'll just drop them down right here. There's my resistor, there's my device, and I can go into the constraint manager and just take a look at this. So I can see that the mynet is attached to the constraint set, also called mynet. I do need to just import that rule from the topology file that I had right here. So that is this one right here. Let's bring that one in, and I'm going to overwrite it, and then you can see my rule pops up here telling it that the min is 500, max is 1500. Once that's rules in there, I can now go ahead and route this net. Notice I'm in the OrCAD PCB level of the tool, and I can route it right here and complete my routing there and finish up my routing from the other side like that. And notice in the lower right hand corner my etch tells me that it's green. Everything looks good. You can zoom in here and see that it looks okay. Go to the constraint manager and just verify that by selecting Analyze, and you can see that it comes back telling me the actual length is 1141, which is 641 mils more, and it's also less than the maximum. So this looks great. Everything is constrained correctly from Capture, then routed correctly in the board, and you can then go across and verify this in Signal Integrity tool again afterwards if you want to. So if you want to now, you could go to the probe tool and you could select your net, view the topology, and rerun the simulation again if you want to. So I'll just extract this off to the SI tool. Here I am at the SI tool now again with real trace lengths in here, and I have my drivers, receivers again. I could analyze and verify that everything is correct now. Thank you for watching. I hope you liked the demonstration of the new flow in 16.6.